Kurtosis. So what is kurtosis measuring? So kurtosis is measuring the extreme values in the either tail. If you remember skewness was measuring extreme values in one side of the tail, right? So that is a difference. So if you remember, we did skewness also. So it was measuring the extreme values on one side of the tail. So either on this side or on this side. Now, kurtosis is going to measure the extreme values on either tail, right? So please write this. Kurtosis measures extreme values in either tail. While skewness measures extreme values in one versus other tail. First thing is that, right? So first point is that. Second is, so it is describing the peak of the data. It is describing the peak of the data and how the data is distributed around that peak. That is what kurtosis is trying to describe. So please write. It describes the peak of the data and how that data is distributed around the peak. How that data is distributed around the peak. One thing is that, right? Well, if you look at this, so here the peak is coming out here. So if you just make a graph like this, so it is going to be like this. Like this. Huh? So here the peak is coming here. Yeah. Okay. What about this? So here the peak is coming here. It is little flatter. What about this? Here the peak is coming. Here it has a lot of peak. It has a lot of peak. So this guy has high kurtosis. This guy has low kurtosis. So let me write few points. This is low kurtosis. This is high kurtosis. Okay, what else? If you look at it this way, this distribution, your high kurtosis distribution, the distribution is less centered around the peak. I mean, if you just have a look at that, so it is less distributed around the mean or around the peak. Well, if you compare this is distributed more around the peak. One thing is that. So there are extreme values on the tails. There are extreme values on the tails. And so you call this as high kurtosis as that situation which has skinny tails. And this is less concentrated around an average. I'll give you an example. Let me write a few points. So high kurtosis has fatter tails. And less concentrated around an average. And less concentrated around an average. So for example, if let us say most of the people are not retiring around the age of 60. So there are people who are retiring at the age of 60. But there are people who are also retiring, let's say, at the age of 40. Sometimes some of them are retiring at the age of 70. But somehow your average is coming around 60. But there are extreme values which are present, right? So that could be the case of high kurtosis. So they are less concentrated around the average. But in case of low kurtosis, so for example, there are very few people who are not retiring around the age of 60. So there are people who are retiring at 59 or 61, but there are very few people who are retiring at the age of, let's say, 50 or 40, or there are very few people who are retiring at the age of 70. So there is a less chance of extreme values. So in case of low kurtosis, you have skinny tails. So skinny tails means you have less extreme values. Skinny tails. And distribution is more concentrated and distribution is more concentrated around an average. So if you just look at this, there is a hump in between somewhere, right? And you have a very less data on the tails, no? So you don't have much extreme values here, but you have extreme values here, right? So that is what is meant by fatter tails. And you have less extreme values here. So that is what is meant by skinny tails, right? So the data which is showing the fatter tails, you can say the distribution exhibit tails. I mean, you can say it like this, that is, this kind of distribution, your high kurtosis distribution, is showing you the data which has the tails which are exceeding the tails of the normal distribution. Normal distribution is the center point, is the point with which we are comparing, right? So you are saying that as compared to the normal distribution, high kurtosis data would have more values on the extreme, right? So distribution exhibited tail data exceeding the tails of normal distribution. The tails of normal distribution. And what about this guy? Your low kurtosis. Low kurtosis would be the case where the tail data which is being exhibited in the low kurtosis case will be showing less tail data as compared to the tails of the normal distribution, right? So you have the less data on tails. That means it has the skinny tails. So it exhibits tail data. So when I say tail data, it means the extreme value. So it exhibits tail data that are generally less extreme. That are generally less extreme than the tails of normal distribution, right? Than the tails of normal distribution. Now, the point is this. You call this kind of the distribution, right? Your low kurtosis distribution as platykurtic, and the high kurtosis distribution as the leptokurtic, right? And the normal distribution you call as mesokurtic. So let me just write these points. This is normal. So this is called mesokurtic. This is called mesokurtic. There is one more concept which is related to this, and that is called the excess kurtosis. So excess kurtosis is measuring what? It is comparing the kurtosis of the distribution as compared to the normal distribution, right? So the kurtosis of the normal distribution is 3. So if any data is going to exhibit the kurtosis which is more than 3, you call that as an excess kurtosis, right? So that is what excess kurtosis is. So before writing mesokurtic or leptokurtic, let me just write one point. Excess kurtosis howsoever I try, I'm not able to make small videos. So when I start making it, I think, well, let me just discuss this also, discuss that also. Is a metric that compares the kurtosis distribution against the kurtosis of a normal distribution. So kurtosis of the normal distribution is 3, and the excess kurtosis is the kurtosis of the distribution minus 3. Kurtosis of the distribution minus 3. So a mesokurtic distribution is more or less like your normal distribution. So it has an excess kurtosis of 0 or close to 0, right? So excess kurtosis for the Mesokurtic distribution is 0 or close to 0. So kurtosis is around 3 or close to 3, right? So this data Mesokurtic distribution, it follows the normal distribution. Your Leptokurtic distribution, that is what your high kurtosis is. Leptokurtic distribution. Leptokurtic distribution. So it has the kurtosis of greater than 3 and excess kurtosis of greater than 0. Right? Excess kurtosis of greater than 0. So they have the heavier tails. They have the heavier tails on either side. So it means that there are large outliers which are present. You remember now? So many people who are also retiring at the age of 40 and 70, not necessarily just 60, right? Something like that. So large outliers. And if you look at it from the point of view of finance, your leptokurtic distribution is actually showing that the investment could also give you sometimes extreme returns. These extreme returns, they could be positive, they could be negative. So it depends. So, and when you have an extreme result, extreme returns which are going to be there in the distribution or in the investment portfolio, that kind of investment is considered to be risky, right? So when you have outliers which are present, so maybe you might lose everything or you might gain a lot of things. That is a risky venture. So leptokurtic is sort of related to risky. So the investment whose returns they follow leptokurtic distribution is considered to be risky. What about platykurtic? This is platykurtic. Platykurtic, right? So it has a negative excess kurtosis. So it has the excess kurtosis of less than 0. And kurtosis of less than 3, right? So there are few outliers or very less probability of outliers, no? Few outliers. So, and in case if the investment is following the platykurtic distribution, it means that there is a less chance of having outliers, less chance of having extreme returns, less chance of having extreme loss or extreme gain. So this is considered to be safe, no? This is considered to be safe. And if you just want to plot this in one go, so you have this guy, right? This guy is what your Mesokurtic is, black one. Right? And this guy is your Leptokurtic. This guy is your Leptokurtic, red one. right? And this one is your Platykurtic, green one. Platykurtic, right? So this is what we have done: kurtosis and types of kurtosis. We have done kurtosis and types of kurtosis. This is what we have done, right? Thank you, Beta.